Today, we are going to practice graphing linear equations written in standard form. We're going to do this by finding the x and y intercepts. We will look at an example where this method works well, an example where it's doable under the given conditions, and a third example where another method should probably be used. So let's get started. So here we have the linear equation 2x plus 5y equal to 20, and this is written in standard form. In standard form, we have our variables, in this case the variable x and the variable y. Well, they're on one side of the equation, and they each have a coefficient that is some number, and this is equal to some other number. This means it's in the form ax plus by equal to c. We can graph the equation of a line if we know any 2 points that are on that line. So for example, if I have a point here, and this is not related to the equation, and then I have another point up here, so I can draw a line connecting those 2 points. And I can extend that line beyond each of those points as well. Now this was just a random 2 points. Now let's find 2 points that satisfy this relationship. So an ordered pair, x and y, that when we plug it in, will be equal to 20. Well, we can do this by making a table of points. So we'll have an x and y coordinate. And let's start with an x value equal to 0. So what will that y value be? So we have 2 times 0 plus 5y equal to 20. Well, 2 times 0, anything times 0, that's 0. So now we have 0 plus 5y equal to 20. And that's just 5y equal to 20. Now we want to go from 5y to 1y. So to get rid of that coefficient of 5 and change it into a 1, we're going to divide by 5. 5 divided by 5 is 1. So that gives us 1y, or just y on the left. But what we do to one side, we have to do to the other to keep the equation balanced. So that gives us a y value of 4. So our y value is 4. So this means we have the ordered pair 0, 4. So let's graph that point. Starting at the origin, we're not going to move to the right or left because our x value is 0. And we're going to go up to 4 on the y-axis. So in this case, we have found the y-intercept. And that is the ordered pair 0, 4. So now let's try another point. In this case, instead of setting x equal to 0, we're going to set y equal to 0. So when we do this, we now have 2x plus 5 times 0 equal to 20. Again, this goes to 0. 5 times 0 is 0. And we can skip that 2x plus 0 step, and we can write that as 2x equal to 20. And now we don't want a coefficient of 2 in front of our x. We want a coefficient of 1. So we'll divide by 2. This gives us 1x, or x on the left, equal to, and then we have to divide the right by 2 as well, and we get x equal to 10. So now we have the ordered pair 10, 0. So let's plot that point. So we have an x value of 10, so we'll move over the 10 on the x-axis. The y value is 0, so we're not going to move up or down. And so here is our x-intercept, and this is at 10, 0. We now have 2 points, and we can connect those 2 points with a line. And we have now graphed the linear equation 2x plus 5y equal to 20. And we did this by finding 2 points, and those 2 points were specifically the y-intercept And we found this by setting x equal to 0. And then we also found the x-intercept. And we found this by setting y equal to 0. Now this example worked out nicely because both our y-intercept and our x-intercept were integers. And with this graph provided, these points fall on our grid lines. Let's try another. We have the equation 10x minus 3y equal to 15. And our goal is to graph this line, and we're going to do this by finding the x and y intercept. So I'm going to start by creating that table. Again, you can pick any 2 points that are on this line. I choose to find the x and y intercept because they're often easier to find because we're setting one variable equal to 0. So let's start with that y-intercept first, where x is equal to 0. So we'll have 10 times 0 minus 3y equal to 15. And 10 times 0, that's 0, it goes away. So now we have negative 3y equal to 15. Then we're going to divide both sides by negative 3. So our y coefficient goes from negative 3 to 1. So we have 1y equal to negative 5. So our y-intercept is 0, negative 5. So plotting that point, well, we're not going to go left or right on the x-axis because our x value is 0. And then we're going to go down to negative 5. And we have our y-intercept, and the ordered pair is 0, negative 5. Now let's find that x-intercept. And with the x-intercept, we have a y value equal to 0. So this is 10x minus 3 times 0 equal to 15. Again, multiplication by 0 gives us 0. So we have 10x equal to 15. Now we're going to divide by 10, giving us 1x equal to 15 tenths. Now we can rewrite 15 tenths. This is 5 times 3 all over 5 times 2. So those 5's cancel out. That's equal to 3 halves. And then another way of writing 3 halves is as 1 1/2, or as the decimal 1.5. So I'll go ahead and put this as a decimal 1.5 here in our table, but it does not matter. You could have written any of these forms. I don't recommend 15 tenths because that's not simplified down. So now let's plot that point. So starting at the origin, we're going to move 1.5 spaces, or 1 1/2. So we'll go to 1, and then halfway between 1 and 2 is our point. So the x-intercept has an ordered pair of 1.5, 0. And then we can draw our graph through these 2 points. So on this graph that I have here, the grid lines are already labeled. So the difference between each grid line was 1. So 1, 2, 3, 4. Now if you have your own graph paper, you could have changed this up and put maybe 1/2 as the distance between each grid line. But for this example, the graph was provided for me and I couldn't modify it. Now this method is okay because although one of our intercepts was not an integer, it did have a denominator of 2. And it's not very hard to find the halfway point between 2 grid lines. Let's try one more. And in this case, finding the x and y intercepts may not be the best course of action for graphing this line. But let's try anyway and see what we get. So here we have 3x minus 5y equal to 20. Yeah, we're going to start with our table. We're going to find couple ordered pairs that are on this line. Specifically, we're going to find that y-intercept, where x is equal to 0, and the x-intercept, where y is equal to 0. So when x is equal to 0, we're going to have 3 times 0 minus 5y equal to 20. Again, this goes to 0. We have negative 5y equal to 20. Dividing both sides by negative 5, so we have a coefficient of 1 in front of our y. We end up with y equal to negative 4. So we have the ordered pair 0, negative 4 as our y-intercept. So let's plot that point. Again, starting at the origin. So we'll go down to negative 4. So we have our y-intercept with an ordered pair of 0, negative 4. Next, we have y equal to 0 to find that x-intercept. So we have 3x minus 5 times 0 equal to 20. This goes to 0. We have 3x equal to 20. Dividing both sides by 3, we end up with x equal to 20/3. This fraction does not simplify down any further. But we can write this as 6 2/3. Or if you want to write this in decimal form, this would be 6.6, and that 6 is going to continue on forever. So let's write this as 6 2/3 for our ordered pair. So graphing this x-intercept, we're going to go over to 6. So 1, 2, 3, 4, 5, 6. And then we're going to go 2/3 over to 7. So we're going 2/3 the distance between 6 and 7. That's approximately there. And you can probably kind of hear my hesitation in this voice because we're starting to lose a bit of accuracy here. Because 6 2/3, it's a little more difficult to find that on this graph. But there's our ordered pair. And then connecting those 2 points, we have our line. For this example, I was okay at estimating halfway between 2 grid lines. But with this one, trying to find 2/3 or 1/4 or 20% or 95% of the way from one grid to the next is probably not ideal. But I didn't know it until I got to the very end. Is there a quick way to find out whether or not using x and y intercepts is a good method for graphing an equation that's written in standard form? Yeah, there's some quick checks we can do. Let's look at this first equation. So when I'm deciding whether or not to find the x and y intercept in order to graph an equation written in standard form, I look at my numbers. So I look at this number that's all by itself, and I say, is it divisible by the coefficients of x and y? So if I go 20 divided by 2, is that going to give me an integer? Yeah, that gives me 10. And then doing it with the other coefficient, we have 20 divided by 5. Well, that's going to give me 4. So when we have things in standard form, so that ax plus by equal to c, if c is divisible by both a and b, I'm going to end up with integers for x and y intercepts. And that's a great example to graph using this method. Now for the second example, again, I'm looking at c, I'm looking at 15, and I'm asking, is it divisible by 3, and is it divisible by 10? Well, 15 divided by 3, yep, that's 5, that's good. But 15 divided by 10, well, that's going to give 3/2. Although that's not an integer, it does have a denominator of 2, and graphing halfway between 2 grid lines is not that bad. So it may not be ideal, but it's an okay method. So let's try this for this third problem. So here we have 20, and we're checking to see if it's divisible by 5 and by 3. Well, 20 divided by 5, that's 4, so that's good. And 20 divided by 3, well, that's going to give us some number. And then we're going to have 2/3 left over. In finding that 2/3 distance between two grid lines, pretty much any fraction other than a half, I'm going to probably avoid using this method. So I probably would not use this method to graph this particular equation. What would I use? Well, I'd probably rewrite it in slope-intercept form. So if we did that, well, we have 3x minus 5y equal to 20. So we'll subtract 3x from both sides. We now have negative 5y equal to negative 3x plus 20. And then dividing everything by negative 5, we'll now have y equal to positive 3/5 x minus 4. So from here, we have our y-intercept of negative 4 and a slope of 3/5. So graphing this, well, we have our y-intercept at negative 4. That hasn't changed. We're going to rise 3 and run to the right 5. 3, 4, 5. That's on the line. And then we can rise 3 and run 5. We end up with the same line. So plotting this line with the slope-intercept method, I have more confidence in the location of these points since they are on grid lines, as opposed to this approximation of the x-intercept. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these two problems. So with this first example, we have x minus y equal to negative 5. So 5, or negative 5, is divisible by 1. So finding the x and y intercept is a great method for graphing this line. When x is equal to 0, we get a y-intercept of 5. And when y is equal to 0, we get an x-intercept of negative 5. Graphing those 2 points, we can draw our line. With this second equation, we have 3x plus 8y equal to negative 24. Again, if we look at negative 24, it is divisible by both 3 and 8. So finding the x and y intercepts will be a good way to graph this equation. When x is equal to 0, we have a y-intercept of negative 3. When y is equal to 0, we get an x-intercept of negative 8. Again, plotting those 2 points, we can draw our line. Drop any questions you have in the comments. Continue practicing graphing linear equations written in standard form, and I'll see you in the next video.